Hello friends, welcome to the channel Can You Solve It? Today we are going to solve a coded multiplication problem. In a certain multiplication problem, each digit from 0 to 9 was replaced by a different letter, resulting in this coded multiplication. We need to find the numbers which were represented by these letters. Before we go ahead with solving this problem, let me refresh your memory about long multiplication. In this example, 768 is multiplied by 423. To get the result, the process is we multiply 768 by 3. 3 times 8 is 24, write 4 below and 2 is carry. 3 times 6 is 18 plus carry 2 is 20, write 0 below and 2 is carry. 3 times 7 is 21 plus carry 2 is 23, write the entire number below as there is no number left for further multiplication. We repeat the process by multiplying 768 with 2 and 4, but writing the result one position to the left respectively. And then we add all the results to get the answer to the long multiplication problem. Now in the problem asked, the digits from 0 to 9 are replaced with letters. We need to decode the letters and find the corresponding numbers. Let's get to it. These are all possible number combinations for the unknown letters. What we can tell about the letters from the problem is the first letters in each row cannot be 0 because these are all 4-digit numbers. Also, none of the digits in the number RUM is 0. Why? Because if ALE is multiplied by 0, we should get all zeros in the result, which must be represented by same letter. But none of the individual multiplication results are represented by same letters. Now from the addition of n plus L, which is equal to n, we can determine that L is equal to 0. Let's substitute L in the matrix and in the problem. Now M times C must be NE and M times A must be WI. Why? When M is multiplied by E, N must have been the carry. M times 0 is 0. We add the carry N to 0 and write the result N below. No carry remains and hence M times A is WI. Similarly, the other equations are also true. Among all these equations, the simplest one to decode would be U times E is W0. To get 0 in the first digit, one of U or E must be 5 and the other digit must be an even number. Let's assume that U is 5, then E must be 1 among 2, 4, 6, 8. Let's take E as 2. Now from the equations M times E equal to NE and R times E equal to WE, what we can tell is that out of all possible combinations of multiplications, only 2 satisfies these equations. These are 1 times 2 is 0, 2 and 6 times 2 is 12. Out of these two multiplication results, 1 times 2 equal to 0, 2 is not possible because it implies either N or W is 0. But we have already determined that L is 0. So this result is not possible. So now the only possible multiplication is 6 times 2 equal to 12. But this result is true for both the equations. This means both M and R should be 6 and both N and W should be 1. But it is given in the problem that each number from 0 to 9 are uniquely represented by the single letter. Hence, M and R both cannot be 6. This means our assumption that E equals to 2 is not valid. With similar reasoning, we can prove that E cannot be equal to 4, 6 and 8. So our original assumption that when E equals to 5, E must be from 2, 4, 6, 8 is wrong. This implies that U is not equal to 5 and E is 5. Let's substitute 5 for E in the problem. Now from the equations m times 5 equal to n5 and r times 5 equal to w5, what we can tell is m and r must be among 379 from these results. Also n and w must be among 1, 3, 4. Let's take another equation r times a equal to 5w and substitute all possible values of w in the equation. Now w can be 134. You can see from this table that only 54 is resulting in a multiplication of two single digit numbers 9 and 6. This implies w must be 4. Between 9 and 6, r cannot be 6 because r must be among 3, 7, 9. That means r is 9 and a is 6. Now let's take the equation u times 5 equal to w0. We know that w is 4. That means from this equation we get u is 8. Now we have determined the values of 4 letters. Let's substitute these in the problem. Now from the two equations m times 5 equal to n5 and m times 6 equal to 4i, what we can tell is m cannot be 3 because it doesn't satisfy the equation m times 6 equal to 4i. 3 times 6 equal to 18 only. However, m equals to 7 satisfies both the conditions. So m is 7. Now m times 5 equal to n5. That is 7 times 5 equal to 35. This implies n is 3. Also m times 6 equal to 4i. That is 7 times 6 equal to 42. This implies I equal to 2. Now the only number which is not assigned to any letter is 1 and it should be p. Now we have determined the values for the remaining 4 letters. Let's substitute these in the problem to get the solution. So the original problem is the long multiplication of 605 times 987. You can verify the result by using calculator. That's it. Thank you. Hope you enjoyed solving this puzzle. Don't forget to subscribe to this channel if you haven't done it already for getting updates on more interesting puzzles. See you on the next one.